Chapter 24 is titled Slopes, and we're moving into a group of chapters where we're going to be talking about these linear equations that we've looked at so far, and we want to know how to graph them. Okay, and the linear equations involve two variables, an x and a y. And so when you graph a line, you probably already know that you know how to draw a line. It's several different types of lines. Um, from left to right, we could have a line that points upward. We could have a flat line. We could have a line that goes straight up and down, or we could have a line that goes from left to right and goes downward. And there's all sorts of different slopes in between there. Okay, compared to this one, if I wanted to draw one with a less steep slope, okay, I could draw these two. Maybe that last one's not too much different from the first one, but almost flat. Okay, so these two would have a smaller slope than this one. Okay, if I wanted a steeper slope, then I could draw one that is almost completely vertical. But as we go from left to right, we're still traveling to the right and we're dropping pretty fast. Likewise, with this positive slope, I could draw a slope that is steeper. And so the more steep, whether it goes up from left to right or down from left to right, we say the slope increases. Okay, now one of these is going to be a negative slope and the other would be a positive. Alright, and so for a large slope, what we would have is a large number on the top for the rise. Let's say we had 5, and then the run 1. This would be a pretty steep slope. Basically what that would mean is if we started at one point, we could locate a second point by simply following these instructions, which are telling us to go to rise 5, to change our altitude by 5, and then to change our horizontal position by 1. So we would go up 1, 2, 3, 4, 5. Okay, and so sort of ran out of room there. Let me move this over and draw it here. So we can go up 1, 2, 3, 4, 5. This would be a rise of 5. And then we would go over to the right 1 unit. And when we were graphing things on a number line, we said to the left is negative and to the right is positive. The same applies to the run. And then with the rise, if we have a vertical number line, then going down is the negative direction and going up is the positive. So if I use a slope of plus 5 over plus 1, then I go up 5 and to the right 1. So this slope of 5 would create a pretty steep line. The line would pass through these 2 points here, and I may have not connected them very well, but hopefully you get the idea. Alright, the variable that we use for slope is m, and so either one of these represent rise over run. Okay, how much we go up or down divided by how much we go left or right. And again, up, down, left, right, the difference would be in the sign. So here in the next page, we're given a line that's graphed on our two-dimensional plane, and we talked about the 2D coordinate system that we're going to use in the previous chapter, chapter 22. And we also, in 23, talked about what a linear equation looks like. So I don't know exactly what this line is, but I know it's going to have the general form of ax plus by equals c. Okay, and notice that I didn't write m anywhere in this equation. Okay, that's because in the form that it is now, m doesn't actually represent one of the coefficients in this general form of an equation. And again, you can recognize a linear equation by the exponents of your variables, and in each case you have two variables for a linear equation, and in each case the exponent is 1. And what we want to do, we don't want to come up with the equation, we simply want to calculate the slope. So m equals rise over run. Alright, what you want to do to calculate the rise and the run is have two definite coordinates on your line, and that's what we're given here with these two solid dots. In other words, we wouldn't want to, if we were picking our own points, we wouldn't want to pick some point in here or there, because we're not really sure what the coordinates are. And so we want to, okay, if we mark those out, we want to pick points that cross right through the intersection of some of these grid lines here. And so here's another possible point that we could have used to calculate our slope. But we'll stick with the ones that we were given in the first place. Okay, we don't want to approximate these coordinates. So first what we'll do is we'll just use the rise over run method. And when we figure out what the rise and run is, we only want to move vertically, straight up and straight down, to calculate the rise. And then for the run, we want to move right or left. Okay, so vertically or horizontally. We're not going to move diagonally and count any units in that direction. So if I start here at this first point on the left, start, there's actually two ways by moving vertically and horizontally that I could get to the second point. I could track along this path. I would go up and then to the right, or I could track along this path. What you have to realize is that either path is going to give you the same rise and run. Okay, so the way I drew these paths is I went straight up until I was horizontally in line with the second point. So up until we're in alignment with the second point, and then you simply want to run straight across perfectly flat to the right and arrive at the second point. So this top piece of our path would be called the run, and the side piece would be called the rise. Alright, for the other path we would have this side is our rise, and they're the same number. And then this bottom side, like the run on the top, would be the run. So either way you go, you're going to get the same number. From this point up to this intermediate point, we went up, and so that would give us a positive value for the rise. And how many units? Well, there's 1, 2. We went up 2, so a plus 2 for the rise. And we're temporarily located right here on the y-axis, and to finally arrive at our second point, we have to go to the right in the positive direction, so the run would be positive, and then we have to go 1, 2, 3 units to the right, so the run would be a plus 3. So we have a slope of 2/3. Okay, the slope is simply a number. It doesn't have any variables contained in it. This describes the steepness of our line. Okay, so this number would be inserted into our equation. This m equals 2/3 does not represent our equation. Okay, this is just simply the slope. Alright, and that's exactly what they did down here at the bottom of the screen. They just sort of zoomed in on this piece where I drew our dotted lines for our path, and they got the same thing, 2/3. And then at the very bottom they point out that what you could do, they have negative numbers here and the arrows aren't exactly in the right position. They're telling us we could have started at this upper point and moved to the lower point. Okay, so in this picture what happened is we started at this one. If we're to get a -2, if we started at the top one and we went down in this direction, so you can see that the arrows are just simply on the wrong ends of these little brackets. And so if we were to start at the top one and go down and calculate our slope with rise and run, we would have a rise of -2, because starting at the top one we have to go down, and then we're level with the second point, so temporarily we're located right here at the X. And so our rise is -2, and then to finally arrive at the bottom point we would have to jump over 1, 2, 3 units to the left, and the left is the negative direction, so for the run we would have a -3. And you see that we get the same value for the slope, because a negative divided by another negative is still positive, so 2/3. So you can start with the leftmost point and go to the right, or you can start on the right and go to the left, as long as you have your signs correct for the directions that you travel. Okay, example 1, here's one that we can work out ourselves. So if I start at the top one, and then I finish at the bottom one, I want to go perfectly horizontal and vertical. So let's say we go to the right first. We have to go to the right in order to line up with the second point, and so I want to go over to the right until I'm directly above it. Alright, the formula for the slope you need to just memorize: rise over run, fraction form. And what we've done is we went to the right, and so we actually calculated the run first. Alright, left and right is your run, up and down is your rise. So starting with the one on the left, we went to the right 3 units, 1, 2, and then 3. So for the run right is positive, and 3 for the number. And we're temporarily right here at the X, and now we want to go travel vertically to our point. And if we go down 3, we've made it to the second point. We went down, so the rise is negative, and we also traveled 3 units. Okay, so we can simplify the run, or I'm sorry, the slope. It's just a fraction, and 3 divided by 3 would give us a 1, but then a negative divided by a positive would keep the 1 negative, and so we have a slope of -1. So likewise, if you were to have traveled, let's pick 2 different points. I'll pick this point. It crosses right through the intersection of 2 grid marks, and I can use a rise over run, any numbers that I want to for rise and run, as long as the 2 numbers combine to still give me a slope of -1. So I could have used a -2 over 2 if I wanted to. Okay. And what that does is it tells me to start at my first point. Mm. Alright, so had a little trouble with my pen. Hopefully that straightened out. But like we were saying, we had an overall slope of -1. So any combination of rise and run that would lead back to an overall slope of -1 will take me to a second point on the line, as long as I start at a first point on the line, and I'd pick this one. And so in other words, if I rise -2, which is to say to go down 2, 1, 2, and I'm temporarily here where at this intersection of grid marks, and then I run 2, and with it being positive, that means I go to the right 2 at this point, completely horizontal, and I end up at a second point on my line. So I could continue to do that indefinitely, and I would always end up back at a point on my line. So if I go down 2 and then to the right 2, I have found a third point on my line. So I can simply apply the slope as many times as I want to and create as many points along the line as you need. Okay, so when we're given a graph, it's usually more convenient to use the previous method of thinking in terms of rise and run. As long as we can easily locate some accurate points along the line, ones that land at the intersection of grid marks, then we can accurately calculate the slope from the graph, rise and run. Now, what if we're not given a graph of the line? What if we're just given 2 points, the coordinates, 2 ordered pairs that fall on the line? Well, if you think about the rise, it's basically the vertical distance in between the 2 points, and what determines the vertical position are the y coordinates, y2 and y1. So if we have 2 points, in order to calculate the rise, we would simply take the difference in the y coordinates to calculate the rise. And run, we said, was the horizontal displacement between the 2 points. How far are they apart horizontally? Okay, if we were to track one point on the line back to the x-axis and then the second point back to the x-axis, what would be the difference between the x coordinates? That would give us our run. Okay, and so the slope, in terms of calculating the slope with two sets of coordinates, the thing you have to keep in mind is the order of subtraction matters. So if I were to choose to calculate my rise such that y2 comes first and then I subtract the first y coordinate from that, then I have to do the same order for the run. Okay, so if y2 comes first on the top, then x2 has to come first on the bottom, or else you'll get the wrong sign for your slope. Okay, and this next part is just telling us any 2 points that you pick on a straight line, a linear equation, any 2 points you pick on that line will calculate the same slope, rise over run. So here they have given us 2 points, and it actually doesn't matter which one you call the first and the second when calculating the slope. So I could call this the first one and this the second. And usually you orient yourself from left to right. So with this point having an x coordinate of -6 and this one having an x coordinate of 4, this point would fall on the left, so naturally maybe you'd want to call it the first point, but it really doesn't matter. And the reason why we label these first and second is because up above, with our x and our y variables, we have subscripts. Okay, one for the x and one for the y. That just simply means use the x and the y from the first point that you chose. In this case, we have a -6 and a -5. So x1 is -6, y1 is -5. You don't want to mix these up. You don't want to get your x1 and x2 confused. So labeling this second set of coordinates 4, 3 as our second point, that would cause x2 to be 4 and y2 to be 3. Okay, if we plug those numbers into their proper places in the formula we were given above, we just simply take the differences. We have 3 minus a -5, turns out to be 8. And then on the bottom we have 4 minus a -6, we get 10. And it's important to realize that one of these minuses came from the difference, okay, the formula for calculating the slope. Likewise on the top, we have a difference on the top and the bottom. One of these negatives came from the subtraction. The other 2 negatives were the -5 and -6. Those came from the coordinates. So we ended up with minus minus, which is a plus, and so 4 plus 6 gives us 10 on the bottom, 3 plus 5 gives us 8 on the top, and then we can reduce the slope to its lowest terms, numerator and denominator. 8 and 10 are divisible by 2, so in simplest form our slope is 4/5. Alright, and then you see here, what if we would have swapped our points? What if we would have called 4, 3 the first point? Well, you just switch the numbers on the top, and so the -5 would come first, and then we'd subtract the 3 from the 4, 3 coordinates. And so these numbers would just switch positions. We'd still have a minus in between. Now we'd get a -8 over a -10, but a minus minus is still positive, and 8 and 10 are still divisible by 2. So in the end we end up with the same slope. It doesn't matter what order you use the coordinates you're given. You just can't mix x2, y2, and x1, y1. You have to make sure you know which is which. Alright, so example 2, we'll calculate this slope a couple different ways. I'll call this coordinate, set of coordinates 3, 8 the first point, and 7, negative 7 the second. To calculate the slope, you take the difference in the y coordinates and the difference in the x coordinates. And difference means that you subtract. And so y2 would be negative 7. We would subtract on the top, so we bring over this minus sign in between the two y's on the top. So now we subtract the y coordinate from the first point, which is an 8. Now for the run, x2 minus x1, we have x2 is 7, x1 is 3, and we subtract the 2, so we have a minus sign in between them. On the top, a negative 7 minus 8 is a negative 15. On the bottom, 7 minus 3 is 4. Alright, and we leave the slope this way because 15 and 4 don't share a common divisor, and we only have one negative. So in other words, our line would point downward from left to right. It has a negative slope. Okay, so I tell you what we'll do. We'll go back and we'll do this the other way. We'll call this one the second and the other the first, and we'll swap our numbers. So now we're going to get an 8 minus a 7 on the top, and this other 7 is negative, so y2 is now 8, y1 is now a negative 7. So we say minus a minus 7. On the bottom, x2 is now 3, x1 is now 7, and we subtract the 2. And so in this case, this was our old slope, and I'll drop down here below it to calculate this new one. We have 8 minus a minus 7. Well, that's 8 plus 7. We get a positive 15, but then our run turns out to be negative. So 3 minus 7 is a negative 4, and that's the same quantity that we had the first time we calculated the slope. It's just that the negative's on the 4, and in this case, if we wanted to attach it to the 15, that would be okay. It would still represent the same number. We would have an overall slope that's negative, and 15 over 4 would be our fraction, our rise over run. Alright, so let's see. Finding the coordinate that yields the given slope. We have points negative 4 and r, so we're missing the y coordinate of this first point, and I'll call that the first and this the second. So slope m. The formula is pretty simple to remember. You just subtract the y's on the top, subtract the x's on the bottom. You want the x and y with the same subscript, sort of lined up in on top of each other. So 2's, and then our first point coordinates lined up in a column. And so now what we'll do is we'll simply put in what we know, and we'll replace one of the coordinates with an r, and then we'll solve for r. So we know the slope, it's negative 4. Y2 is a negative 9, and we subtract, this minus comes from the formula, an r. We don't know y2, or I'm sorry, y1. Y1 is r. And then on the bottom we have x2, so the x coordinate of the second point, minus the x coordinate of the first, which also has a minus sign. So minus a minus 4 on the bottom. Okay, calculating just simply the bottom of this fraction, I would get a positive 7. And so I have this quantity, this expression, equal to a negative 4. And this is no different from some of the equations that we've solved already. So what we would do at this point is we'd want to solve for r. We'd want to get the r by itself, and so to do that we would multiply both sides by 7. 7 is dividing, so we multiply to get rid of it, and it drops out. Okay, and this was my original expression with r. I changed that to a 7 on the bottom, so I'm not really focusing on this middle part. I just have the right side, the left side. This turns out to be a negative 28. Once the 7 cancels, I have a negative 9 minus r on the right. To get the r by itself, I would now add 9 to both sides, because the 9 on the right side has a negative in front of it. They would cancel. I'd end up with a negative 19 equals a negative r. And so with a negative on both sides, I could just simply drop the negatives, or you could call yourself multiplying both sides by a negative 1. But r would equal positive 19. One way you can look at the slope is to say with the slope of negative 4, recall that if you just have an integer, then you can write it as a fraction by just simply putting a 1 in the denominator. And so if we start out with a set of coordinates 3, negative 9, then we just simply have to apply these changes to the y and the x. So this top number is how much do we change the y, and the bottom number is how much we change the x, and you have to change both at the same time. So in other words, another way we could apply the slope is to say take this y coordinate and subtract 4 from it, and then take this x coordinate and add 1 to it. And we could real easily get a second coordinate set of coordinates on our line. So 3 plus 1 is 4, and negative 9 minus 4 is a negative 13. And you could apply that as many times as you wanted to and come up with as many sets of coordinates that you needed. With that being said, we could also call this a positive 4 over a negative 1. And if we take our coordinate ordered pair 3, negative 9 again, then I could subtract 1 from the x and add 4 to the y, and that would give us 2 and a negative 5. Alright, so what about these two special cases of a horizontal line? Here's our line. Alright, easily confused with an axis. Because this line, since it's horizontal, is parallel to the x-axis. Now, over on the right, we have a vertical line, straight up and down, and that could be confused with the y-axis. Okay, in this case, the actual line is a little bit thinner than the lines used for our axis, and usually the origin is centered in the grid for your two-dimensional coordinate system. So horizontal, vertical. What can we say about their slopes? Can we still apply this calculation of rise and run? Alright, what we'll do is we'll start with the horizontal line, and we just pick any 2 points that we're certain about the coordinates. We know them accurately. Any 2 points on the line. They could be as close or as far apart as we wanted them to be. Alright, any 2 points on a straight line is going to result in the same calculation for the slope. Alright, I picked these two. Alright, so if we apply rise over run, how much do we go up or down in order to be in line with the second point? And if I call this one the first one and this the second one, well, we don't have to go up or down. We're already in line with the second point, and so not having to go up or down means that our rise would be 0. Well, how far do we go to the right? Well, we go 1, 2, 3, 4 to the right, so the run would be a plus 4. 0 divided by 4 is 0. Now, any 2 points would result in this same slope, 0. This is a flat line, so the slope is 0. We don't have to go up or down to get to a second point. Likewise, I could have picked a point further over. Let's say that was my second point. I'd have different numbers for my run. I would now have to go over 1, 2, 3, 4, 5, 6, 7. So my run would be a plus 7. But still, to get to the second point, I didn't go up or down, so the rise would be 0, and 0 divided by 7 is still 0. Alright, so what kind of slope do we get? Well, we get a slope of 0, okay, for any 2 points on a horizontal line. Okay, flat or horizontal line. Okay, so these are sort of cause and effect. If you have a line, if someone told you that you had a line and the slope is 0, then you should know that it's a horizontal line. If someone tells you that, hey, I'm going to hand you this horizontal line, then you should know that the slope is 0. So these sort of go hand in hand together. Alright, what about the vertical line? Well, sort of a different outcome here. If I go to the vertical line, and again you could pick any 2 points, we don't have one that's further to the left or the right. They're both they both have the same x coordinate. So if I call the one on the top the first and the one on the bottom the second, then to go from the first to the second, I don't have to go left or right. And so in the case of rise over run, my run would be 0. Um, but I do have to go down 1, 2, 3, 4. Down 4 would mean that I would have a negative rise, and so I'd write -4 on the top. And it really wouldn't matter what rise I came up with. It could be -5, -10, 10, 1000. As long as I pick two different points on the vertical line, I will have some positive or negative quantity on the top for the rise. Well, when you take a non-zero number and divide it by 0, we get an undefined result. And so we say the slope of any vertical line is undefined. Similar to what we sort of said with a horizontal line, any horizontal line has a slope of 0. Okay, so I could draw a different horizontal line at a different location on the y-axis, but if it's horizontal, it's going to be flat. And if I pick the 2 points and go through the logic of rise over run, then I'm going to end up with 0 again. So the slopes of horizontal and vertical lines do not depend on the position of the line. Example 4 says find the slope of a line passing through the points 6, 5, and 6, -1. To calculate the slope, we just simply pluck out the y's, and I will take 5 first and subtract a -1, the other y coordinate. And since I picked the 5 first for the y's, I now have to pick a 6 first for the x's on the bottom. Difference in the y's on the top, difference in the x's on the bottom, and I subtract 6 from the other point. The x coordinates match, and so when I subtract them on the bottom, I end up with a 0. And 6 divided by 0, a non-zero divided by 0, is called undefined. And so the only line that has an undefined slope is the vertical line. Okay, 2 different points, but now the y's match. We have 4 and 4 for the y's. So if we go through the formula and we calculate the rise on top, the difference of the y coordinates, we end up with 0. And then on the bottom, we could subtract the 2 x coordinates in either order, because either way it's not going to swap. It could swap the 4's, but you'd still have 4 minus 4. So I chose to go with the 2 first, so 2 minus a minus 4, we end up with a positive 6 on the bottom, and 0 divided by a non-zero number gives you 0. So with the slope of m equals 0, we are dealing with a horizontal line. And that wraps up that chapter on slopes. Appreciate you watching. If you have any questions, feel free to come by my office.